I'm Mike Hemsley. I'm an analyst in the power sector at the UK's Committee on Climate Change. We're an independent government advisory body which advises on long-term decarbonisation targets for the UK. And I'm going to talk through today some of the implications of these long-term carbon targets for the UK electricity system. Just a brief overview of what I'm going to cover. Who are the CCC and what do we do exactly under the Climate Change Act? How is the current UK power sector set up? How is progress in decarbonisation to date? And what does this look like to 2020? Then take a step back, look at economy-wide challenges towards 2050 and the role of the power sector within that. Resource constraints for different technologies and the implications of this for investment in the 2020s. And then just summarising by some of our power sector scenarios in both 2030 and 2050. So first of all, the Climate Change Act was introduced in 2008, and it's a target of 80% greenhouse gas emission reductions on 1990 levels by 2050. So quite stretching ambition. Within this, we break up the path to 2050 into 5-year carbon budget periods in order to provide medium-term targets to government, so government can produce policies in order to meet these targets, and to business and industry and consumers as well, so they can adapt over the medium term. These carbon budgets represent cumulative emissions over a 5-year period. So this allows to better manage individual fluctuations in greenhouse gas emissions over 1 year, where, for example, it could be particularly cold, people use more gas for heating, and emissions go up because of that. So we advise government on the level of these carbon budgets. The most recent we've advised on is the 5th carbon budget, which is the period between 2028 and 2032. Once the government has accepted that advice, which they have, then they have a duty under the Climate Change Act to produce policies and proposals outlining how they intend to meet the emissions reductions in our 5th carbon budget. And their latest plan for this is due imminently for policies and proposals to meet the 5th carbon budget. Lastly, after this and alongside this, we developed a detailed indicator monitoring framework for each of the sectors that we cover here, and in order to assess the government's progress in decarbonising emissions. Just for a bit of context, this is where UK power sector emissions sat in 2015. So it's 25% of UK CO2 emissions and slightly less for greenhouse gas, and that was already down around 5% on 2014. So the power sector is somewhere where we're already seeing progress. For example, since 1990, we've just about halved the emissions intensity of the power sector, so the emissions of carbon for each unit of generation that we have on the electricity system. This was due to gas coming online in the 1990s, and then more recently an increase in renewable energy, which now makes up around 25% of the UK's electricity generation. Even more recently than that, an increase in the carbon price floor in 2015 is pushing old coal power stations off the system in favour of gas, so we'd expect to see even bigger emissions reduction in 2016. Alongside that, the government has been active in contracting for more renewable energy to come online by 2020, and we estimate around 30 terawatt hours of additional low-carbon generation could be online by 2020, which is roughly equivalent to around 10% of the UK's current electricity generation. So we envisage significant decarbonisation already in the power sector towards 2020. The rest of this presentation is going to be covering what you do beyond 2020. If we just take a step back for a second and look at the scale of the emissions reduction challenge to 2050, you can see that it involves a dramatic cut. For some sectors within this, we know that there's low carbon options already. For example, in the power sector, you've got renewables and other low carbon forms of generation, which are increasingly cost competitive with fossil generation facing a carbon price. In transport, for example, we have electric vehicles, which are becoming an increasingly trendy option, and the deployment of that is something that's happening at the moment. Other sectors, you can see it's going to be a bit more difficult to decarbonize. For example, heat pumps are a low-carbon electricity option around Europe, but they're not very prevalent in the UK, so there's questions of how to introduce those into the UK's housing stock. And then there's other sectors where long-term we don't yet know if it's really possible to reduce their greenhouse gas emissions to zero. For example, in agriculture, could you ever have zero emissions there? International aviation and shipping, and some parts of industry as well. So on the path to 2050, like I said, we divide it up into 5-year periods. We're currently towards the tail end of the 2nd carbon budget, and the government's legislated the 5th carbon budget, which is that 57% reduction in emissions on 1990 levels between 2028 and 2032. And no, we don't just draw a straight line between now and 2050. We actually do a lot of detailed analysis and modeling in order to come up with something that looks like a straight line, but it's more of a coincidence than anything. Within that, we use energy system models to look across the economy and the different energy sources that the UK consumes and determine the role of different energy vectors within that and their role in decarbonisation. What these models, and there's two of the big outputs of the big ones here, Times and Markel are listed. What they often choose is the early power sector decarbonisation, so reducing emissions in the power sector towards 2030 already, because options are available and the cost of these options is often cheaper than in other sectors in the UK economy. The second thing this leaves us with is a high range of uncertainty around future electricity demand. You can see in 2050, if, for example, we decarbonise transport and we're running the UK's transport and electric vehicles, and if we have electric heat pumps in every home, then we're looking at around up to 700 terawatt hours a year of demand for electricity over the UK economy. Whereas if we don't do either of those, it might be a slight increase on today's levels, but more around 400 terawatt hours instead. But all of this points to early power sector decarbonisation. So let's look at how we might decarbonise the power sector to 2050. On the left-hand side here, we've got a snapshot of UK generation in 2015, and that big chunk at the top is what we call conventional generation, so fossil generation, which is on the system, which we wouldn't expect to still be there by 2050 necessarily. Next to that, we've got projected demand in 2050 with that range of uncertainty on top. Like I said, we don't know quite that will be. And then the third stack on the right is the potential of the technologies that we believe could be deployed to, in theory, in the UK. So for example, what is the whole offshore wind resource in the UK's waters? And if you were to install machines to capture that energy in those waters, that would be the size of the offshore wind trunk there. Similarly, for each of these technologies within here, there's going to be different issues and different constraints. Nuclear power, for example, the issues on maybe site availability. At the top, there's carbon capture and storage. So this is a process whereby you capture emissions from a more conventional power plant, such as coal or gas generation, and then you bury those emissions underground. Obviously, there might be public acceptability issues around that, and maybe a potential limit to the storage or limited on cost. And so you could go through each one of those and see, okay, some have a clear, large role to play, or at least we'd like to know what their role could be in the future, because offshore wind, for example, could provide almost all of the UK's generation, and some might have more issues around them. I'm just going to pick out offshore wind and CCS within that and talk about those in a little bit more detail, and hopefully I'll be able to explain why. So carbon capture and storage is important, because it's a good option for capturing emissions, and it's important. It can be put to use in multiple sectors as well. It's also, the UK is a good opportunity for it because we have oil and gas fields in the North Sea where we could potentially store carbon dioxide for periods of thousands of years, meaning that this carbon dioxide would be buried and wouldn't affect climate change during that period. Because of its importance to power as a flexible source of low-carbon electricity, so maybe being able to balance renewables on the system a bit better. Within industry, so being able to decarbonize certain point sources of emissions where we don't currently know of any options to decarbonize them. And also potentially combined with bioenergy to unlock so-called negative emissions in the future, which could be important if the sectors where we don't know if we can bring down emissions in the UK. Because of the importance of that, we've commissioned some consultancy work over the last few years looking at how you might reduce the cost of this technology so that you know by, say, 2030 whether it's going to play a big role or whether it's able to play a big role in the economy towards 2050. What that research tells us is that through deployment in the power sector, where you could have large loads of carbon dioxide, which could allow for a shared infrastructure system of transport and storage for carbon capture and storage along the UK's east coast, putting carbon into the North Seabed, and steady deployment of that technology, the UK could reduce the costs of that by, first of all, sharing the network storage assets, by giving the financial community sense that there's something to invest in here, reducing the cost of capital and the risk around these kind of assets, and also potentially have a knock-on effect in global learning around the technology, which means that other countries would work in tandem to bring the cost of these technologies down. Because of that, we recommended to government a program of investment of carbon capture and storage during the 2020s in order to determine whether by 2020 we'll know whether carbon capture and storage is an option for the UK power sector beyond then or not. Similarly, for offshore wind, we saw on the previous chart the size of the potential offshore wind resource in the UK, but as some of you are likely aware, the current costs of offshore wind have been subject to a lot of scrutiny in the press. UK consumers have paid a lot for the first generation of offshore wind in the UK to be deployed, and what they need to see for the next generation of offshore wind is a clear path to cost reduction in order to support this. So we looked at the offshore wind market in the UK and got consultants to look at how costs might be reduced in this sector. First of all, it's important to note the UK offshore wind market at the moment is a large part of the European offshore wind market and the global offshore wind market. So actions in the UK to reduce the cost of this technology may have a knock-on impact elsewhere as well. Also, manufacturers are quite connected in the European market, so if they could see steady deployment in the UK, as part of a wider European market, they'll be able to invest in things like factories, supply chains, which all have a knock-on effect in reducing the cost of these technologies. This similarly came out with reductions due to a step change in turbine size, so moving from the current generation of 4 to 6 megawatt turbines in the sea to 8 megawatt turbines, and potentially even beyond during the 2020s. A reduction in cost of capital, and then other reductions due to research and development as well. 2 years ago, when we were doing this work, the numbers that came out of it looked quite stretching. What we're seeing now is that industry's already saying that their costs in 2020 will be £100 per megawatt hour or below, and they could even go beyond that in the 2020s. So this is very much possible, but to summarize, we need to know in the 2020s whether we can unlock, in a cost-competitive way, that vast offshore resource in the UK beyond 2030, so we know if we can fully decarbonise the power sector to 2050. Just to step back a bit, so far I've outlined the needs of a UK electricity system to 2050 and some of the technologies within that. I haven't really considered the current context of the UK's generation fleet. So this is a slightly old chart, but it just shows that the majority of the UK's generation fleet, which is traditional thermal plants, so gas, coal, and nuclear generation, has been installed over the last 40 years or so, and a lot of it we'd expect to retire up to 2030. Indeed, a lot of the coal that's in there, the government has already announced that it will set a coal closure target date of 2025, so it's likely that all of that will go, and there's a limit to how long the nuclear plants can be extended. So you're going to need some form of generation in order to fill this gap. Taken that as the first message, and then alongside the falling costs of renewable technologies that we're seeing, and a rising carbon price, if you look into the 2020s, you see a range of low-carbon technologies which can replace this generation cost effectively. And those would be quite a few of the technologies that we've seen in the previous charts so far. So taken together, what does this mean for the CCC scenarios to 2030 and beyond? So we've taken the energy system modeling across the economy and looked kind of on a top-down basis, where would you choose to decarbonize first in order to unlock decarbonisation in other sectors? And the result of that is early-stage power sector decarbonisation by 2030 will allow you to have low-carbon electricity for heat pumps in households and electric vehicles in transport as well. Separately, we've also looked on a more bottom-up basis at the potential for each technologies, their resource constraints. We know the site limits for things like onshore wind, for example, and you're going to need some of these big technologies in order to get to the scale of generation we see in 2050. So taken together, a program of investment in mature low-carbon generation technologies, so nuclear, onshore wind, solar, and other options, alongside more innovative technologies such as offshore wind and CCS, could get us to around 100 grams per kilowatt hour in 2030. By then, we'd know that those are cost-competitive options, and we'd be able to see further deployment of those options towards 2050 to have a fully decarbonized power sector by then. Obviously, need to introduce a few caveats here around uncertainty, because projected a very rosy picture into the future, but of course there's a lot of uncertainty around the potential of technologies. For example, will wave power suddenly come along and displace offshore wind in those scenarios, things like that? Or maybe the cost reductions don't work and we have to assess another path along that way, which will also affect the costs. Political factors, just before this session we were discussing the decision in Germany to halt existing nuclear power there. If something similar to what happened in the UK, this might rule out or make us consider alternative options to power sector decarbonisation. And then alongside that, a lot of uncertainty around future electricity demand as well. So just to conclude, the power sector in the UK is already decarbonising, and we believe it has the potential to be fully low carbon by 2050, but obviously there's a lot you need to do on the path to 2050 in order to know whether that's an option. It can play an important role in decarbonising other sectors, so via electric vehicles or heat pumps. It seems that the UK has a strategic role to play in reducing the costs of offshore wind and carbon capture and storage, and for a modest amount of investment in the 2020s, we can find out whether those technologies can play a long-term role in future power sector scenarios in the UK. But obviously there's high levels of uncertainty as well, and all of these paths to 2050 need to be adaptable, and we need to continue to monitor progress in order to adjust trajectories and policies as well alongside that. Thank you very much.